So, good morning, everyone. Good afternoon, everyone, and welcome to this lecture. This is lecture number 2 in electric current, and we are dealing with in the previous class we had seen what happens when a conductor is not connected to a battery. Whatever happens because of random motion, the electrons do have some velocity which can be called as the thermal velocity or the RMS velocity, but because of this velocity, mm, they cannot, no current is constituted because whatever number of electrons go in one particular direction and equal number of protons or electrons, not protons, electrons will move in the opposite direction, so the net current is zero. But as soon as we apply, what do we apply? As soon as we apply the electric field or potential difference, electrons will move opposite to the direction of electric field towards the positive terminal with a speed which is known as the drift velocity, which is very small, but because of this velocity we have a net flow of charge from the positive terminal of the battery towards the negative terminal of the battery, and this is known as your this is known as your drift velocity. Have we seen this? We understand this? Yes or no? No, yes. Huh? Do we understand this?
Yes, sir.
Pakka na, sir? Okay. Now, once we move ahead, we had also seen drift velocity, and we had seen the relation between drift velocity and current NAEVD. Do we remember this relation between current and drift velocity and current and tau? Do we remember this? We had gone through these two relations, and from there we had found out on what all factors drift velocity and current depends on. Do we remember this? Yes or no? Do we remember all these relations that we had gone through? Current, drift velocity, current density, and so on. Do we remember them?
Yes, sir.
Okay. Now we can just start this class and try to put all these formulas together that we have seen so that things become clear in our head. So let us start with all these points. Okay, so we start with all these points. Point number one, we had seen the drift velocity is the speed with which the electrons are moving, and you can write this drift velocity as E by m into tau, where tau was your relaxation time. Do we remember this? Do we understand this?
Yes, sir.
Okay, then we had seen that this mean free path was the average distance they travel, average distance that is traveled between two collisions. Do we remember that, beta? Mean free path, yes or no? No, yes.
Yes, sir.
Okay, so you can remember that mean free path lambda as half into E by m, which is your acceleration into tau square. You can remember it in this way. Do we understand this?
Yes, sir.
Okay. Now we can go ahead, and we had seen that your current I can be written as N A E into V D. Do we remember this?
Yes, sir.
Your current can be written as NAE into VD. Now, what you can see is the next point, that current density J was NE into VD. Yes or no? Anyone can understand these relations? These are all the relations put together. Are we able to understand this?
Yes, sir.
Now, if I just write the value of VD as EE by M into tau, I can write it as what?
I by A, sir.
I can write it as N
I by A.
E square by M into tau multiplied by E. Yes or no? Yes or no? I can write it like this. Do we understand how I've written this? Do we understand how I've written this? I have put the value of VD. I put the value of VD from here into this equation. Do we understand this? Do we understand this?
Yes, sir.
So now I can write this legendary formula, J is equal to sigma E. In fact, I can write this equation vectorly also. J is equal to sigma E, where this sigma will become NE square tau by M. Do we understand what I've written here? You know what this equation J is equal to sigma E is known as? Any idea what is this equation J is equal to sigma E known as? We will come to this equation in just about a little more time. Everyone understands up till here, yes or no? Up till this point, the various relations that we have seen, do we understand these relations, yes or no?
Yes, sir.
Okay, now it's the time that since we understand these relations, we should be able to solve a couple of problems so that we are able to understand these relations. So this is the first problem, and we can expect one problem from this topic, because this topic actually slips in between the major topics. So this is the question that I am presenting to you. A conducting wire of cross-sectional area. Remember, you have to look at the units of cross-sectional area. 1 centimeter square has 3 into 10 raised to the power 23 per meter cube charge carriers. If a wire carries a current of 24 milliamps, what is the drift speed of the carrier? I'll give you 2 minutes to solve this problem. So I think you have tried the question, and how you need to do this. It is a
I
very
equal
simple,
to V equal
straightforward
to I
question.
by A, sir.
I is equal to N A E
I
into VD. So from here I can straight away write VD drift speed
by
I
NMD.
divided by N into A into E. You just have to write it in the correct units. Current I is 24 milliamps, so don't forget that. 24 milliamps, 24 into 10 raised to the power minus 3 divided by number of electrons charge carrier per unit volume in meter cube. So it is given like this. I can write it 3 into 10 raised to the power 23. I hope everyone understands this. I am just putting the values from which are given multiplied by What
1.6 into 2 minus 2.
area is given as 1 centimeter square, 10 raised to the power minus 4 meter square. Remember, everything has to be in SI units, multiplied by the charge of an electron. What is the charge of an electron? You should know the charge of an electron, multiplied by 1.6 into 10 raised to the power minus 19 coulombs. And you should be able to put the values, get the answer, and stay happy. The answer that I'm having is option B. I think you will also get the same answer. Did you get it? No one got it?
Yes, sir.
Okay, congratulations. That means you have done the calculations correctly, and we can now move on to the next question. These are the type of questions that you are supposed to face in the examination. Also, be very careful that you do them correctly. This is the next question coming for you on your screens in a wire of cross section, circular cross section. Remember, most of the time the wire will be of circular cross section. Mind my words. A wire of circular cross section of radius r. Free electrons travel with a drift speed of v when a current I flows through the wire. What is the current in another wire of half the radius, same material, when the drift velocity is 2v? And I will give you 2 minutes. Just concentrate on the formula. These are the type of questions that are more likely to come. Concentrate on the formula, write the correct one, find out the correct ratios, and stay happy. I'll give you 2 minutes to do this. So how are we supposed to do this? The answer is option C. You have to be careful in solving questions of this nature. So the only formula I have is current is N A E V D. You just have to apply this formula. In case of first, the current is I. Number of free electrons, let me call it as N. Area of cross section, here it will be equal to pi into R square into E. The drift speed is given as V. So this is for the first one. Radius R, drift speed V, current is I. This is your green one. Then let me write the next one. Let's say that the current is I dash. Number of electrons remains same because it is the same conductor. Radius has become half, so pi R square by 4. E remains same. Velocity becomes V dash. This is your pink one. You can easily find out the value of I dash. I dash by I. The drift velocity has become 2v. I did not write it. So let me just put it here. 2v. I forgot to mention it. 2v. Now you just have to divide and you will get I dash by I as how much? Half. The new current is I by 2. Was it such a difficult question that you could not do it? Someone is getting the answer as I, someone getting it as 2I, then someone getting it as I by 2. Why are you playing कौन बनेगा करोड़पति? Is it difficult to do? Difficult to write the ratios? Hmm? Tell me what was the problem here, beta? There was no problem, but we could not solve it. That is a very big problem because if we don't know the problem, then it's a big problem. Do we know what was the problem? What were we doing correct or what were we doing wrong? Do we remember? Do we understand this? Can anyone tell me what was the difficulty in this question? What
Yes,
was
sir.
Are understood to you always understand everything, yeah, I know that. What were you doing wrong? That is what I want to understand because I don't understand it. Can anyone help me in telling me, sir, we were taking it this way? Can anyone tell me that? I know that you understand everything. I have no doubts on that. I am such a good teacher that everyone understands it. But I am not going to appear for paper. You have to do it. So you have to tell me what were you doing wrong. Yes, tell me. Okay, as usual, no one. Anyways, I have to move ahead in life. I just can't keep hanging around. So this is the third question that comes for you. Question number 3. A potential difference V is applied at the ends of a copper wire of length L and diameter D. On doubling up the diameter only. So what they are doing is doubling up the diameter D. What happens to the drift velocity? What happens to the drift velocity? And I'll give you 2 minutes to do it. Option C. How did you get option C? It does not change. Remember the formula of drift velocity. That's why I gave you all these formulas together. See this pink formula of drift velocity, which is now in a box. It depends on E. E is a constant, small e, charge of an electron. Capital E, it depends on the electric field. If you change the electric field by changing the potential or by changing the length or whatever, then it changes. It depends on M, mass of the electron, constant. Tau, it depends on the material of the body. If the material remains same, temperature remains same, tau does not change. So drift velocity does not depend on the diameter or the area, and hence the answer is C. It does not change. Do we understand this? Yes or no? No or yes? Okay, so this is how, and this is the reason why we are doing this question, so that we understand the relation and we can remember those formulas that we have just gone through. This is the next one that comes in line. A current flows in a wire of circular cross section with free electrons traveling with a mean drift velocity. Remember, the drift velocity that we have seen is the average of all the drift velocities. Mean drift velocity V if an equal current flows in a wire of twice the radius. Equal current. You have to understand the language of the question. Equal current flows in a wire of twice the radius. What is the drift velocity? You've just done a question that it does not depend on the diameter. Now we have the same current flowing in through it. You have 2 minutes to give me the answer. Well, I think everyone has tried it, and the correct answer is yes. Want to say something? Option C, sir. Option C is correct. Now you have to understand the relation or the difference between this question and the previous question. In the previous question, the potential difference that was applied across the wire was constant. Here, here the current is constant. Do we understand this? Equal current flows. Do we understand this?
Yes, sir.
So now we'll have to understand the relation between current and the drift velocity. Current is NAEVD. Now if I call the first current as I1, first current will be N. Oops. Why does this happen? Okay, current is I1. In the first, number of electrons is N. Let me call the area as pi r square. E into the drift velocity, let me call it as V. This is the first wire. In the second wire, the same current, so let me call it as I1 also. Number of, because it's made from the same material, so it remains same. Radius has become twice, so pi into 2r square into E. Let me call this drift velocity as V1. Current is same. Now you can easily find out the relation between V1 and V. V1 will come as V by 4, and that is the answer that we are looking at. Everyone understands how this is done? Yes or no? No, yes. Paka? Okay, here comes the next one in line. Just be careful to take the right ratios. If you are careful enough to take the right ratios, you should get the answer for this one. This is question number 5, and I hope that you can do it. Two wires A and B of same material having radii in the ratio 1 is to 2 and carry current in the ratio 4 is to 1. What is the ratio of drift speeds? I'll give you 2 minutes to give me the answer. 2 minutes. And option A is the correct option. Oops, what has happened here? Not good. Option A is the correct option. How are you supposed to do this? It's very simple. Again, I use the same formula. I is equal to N A E V D. In the first case, let me call the current as I1. I1 will be N into radius pi r square into E into V1. Then I can write I2 as N into the radius of first wire was r, so the radius of second wire was should be 2r, so pi into 2r square into E. The drift velocity in the first wire was v1. The ratio is 4 is to 1, so in this wire it will be v1 by 4. Do we understand this? Yes or no? Oh, current is in the ratio. Sorry, what I am doing? Current is in the ratio. Sorry. So this is V2. I have to find the ratio of drift speed, and I know their ratio. Their ratio is 1 is to 2. I can just put the values here and I will get the answer. Yes or no? No, yes.
Yes, sir.
I1 by I2 4 is to 1. You just have to divide it correctly. If you divide it correctly, you will get your answer. And the answer I think that you are going to get is 16 is to 1. Everyone got this answer? Yes or no? No, yes.
Yes, sir.
Okay, now this is the one which might require somewhat calculation, somewhat chemistry, but this type of question may come looking at the pattern that I am seeing. So I would like to give you this one as well. So this is the next question that is coming up, and I hope that you can solve it. Let's see if you can do this. If the current flowing through a copper wire of 1 mm diameter, you have to be careful about the units, is 1.1 ampere. The drift velocity of electron is how much? Density of copper is given as 9 gram per centimeter cube. Atomic weight 63 grams. And one free electron is contributed by each atom. Let's see if you can Assemble all the data together and get your answer. This I will call question number 6 or 7, I don't know. You'll have 2 minutes to give me the answer for this one. Be patient and get the answer. I'll give you 2 minutes. Now remember, this question may require certain amount of calculation, so maybe you are stuck in that calculation. I don't want you to get stuck in calculation. I want you to clearly understand the concept of how this question is to be done, and that is the only concern that we are going to solve here. How are you going to solve this question? Okay, to find out the current, we have to find out the drift velocity. To find out the drift velocity Vd, I will have to divide divide current by N A N E into A. Now, E is the charge of an electron. We know it. A is the area of cross section. The diameter is given, so we can easily find out the area of cross section. As far as I, current is there, current is also given. Everything is there. The only thing we have to calculate is just the value of N. Now remember, this N was number of electrons per meter cube per unit volume. Yes or no? Now, per unit volume, you have to find out number of electrons. Now we just use what is given here. One free electron is contributed by each atom. One free electron is contributed by each atom. So we have to find out what? How many atoms are present in 1 meter cube? If we can find out how many atoms are present in 1 meter cube, we will find out how many electrons, free electrons, are present in 1 meter cube. Yes or no? Do we understand this?
Yes, sir.
That's it. That's what you need to calculate. How will you calculate the number of atoms in 1 meter cube? 6.023 into 10 raised to the power 23, which is the Avogadro number. These many atoms have how much mass? That is the atomic mass. So they have the atomic mass of 63 into 10 raised to the power minus 3 kg. I hope we understand this. Yes or no?
Yes, sir.
So from there, what you can calculate? Remember, you have to calculate the number of atoms in 1 meter cube. Number of atoms in 1 meter cube. What is given to you is also should be known. You must know what is density is given. Now, what is density? Density is mass divided by volume. Density is given as mass divided by volume. Using these two things, I have to find out the value of N. How will I find the value of N? From here. N is the number of atoms. N is the number of atoms in 1 meter cube. Yes. We have to relate density with mass of atoms and the atomic mass. Let me give you a shortcut formula for this. So number of atoms per meter cube will be given by your Avogadro number A, Avogadro number divided by the atomic mass in kgs, remember, multiplied by the density. And now you can understand how this formula is coming. Total mass is N multiplied by atomic mass divided by a Avogadro number. That will give you the density, total mass divided by total volume. Are you getting my point? How this formula is arrived? So you can keep this formula. This might help you in solving questions of this nature effectively. The number of atoms per meter cube is Avogadro number divided by atomic mass into density. Now if you put the values here, this is 6.023 into 10 raised to the power of 23 divided by 63 into 10 raised to the power minus 3 multiplied by density is 9 gram per centimeter cube. So it is 9 into 10 raised to the power 3 kg per meter cube. The answer that I have is 8.5. Again, I told you that it will require some calculations. I don't want you to get into those calculations. So whenever such a question comes, this is the value of n that you will get. Now you can put the value of n here in this equation and you will end up with the answer. So whenever you see such a question where they have given you this, unless and until you are confident that you will be able to do all these calculations, because even now the calculation is not easy. You'll have to divide 1.1 by 8.5, 1.6 pi and zero point 0.5 ka square. So if you are short on time, even though you know how to do this question, I would suggest that you give it a skip. Do we understand this?
Yes, sir.
Because it requires a lot of calculations. It requires a lot of calculations, so you can just skip such questions. You can just note this down. The answer for this is 0.1 mm per second. That is what you will get after doing all these calculations. So I'll give you a minute to note this down. Note this down till I give you the next question. Everyone has understood how I have done this or how this question is done? Yes or no? No, yes.
Yes, sir.
Pakka?
Yes, sir.
And I would suggest that if such a question comes, you just skip it up and move ahead in life, because this will require calculations. If you do a single mistake, you will not be able to get the answer. It will require a lot of time. You don't have time, because time is a luxury that we don't have, and we must avoid spending time into solving one question which has taken up the time of 5 questions. Have you noted this down, everyone?
Yes, sir.
Note down the formula that I have given you to find out the number of electrons per unit volume. It is basically I have found out mass per unit volume and divided by the Avogadro number, something like that. Just remember this. Noted this down. Can you move ahead?
Yes, sir.
Now, this is the question. As I told you, we discussed one section of this question in the previous class, truncated cone. And I showed you the question that came in JEE of the last year, JEE Advanced. This is another variation of the same question. If you are lucky, maybe this question may come this time in your JEE Main or Advanced. Figure shows a conductor of length L carrying current I and having a cross section. The radius of the cross section varies from A to B. Assuming that B minus A is very, very small compared to L, give the current density at a distance x from the left hand. It's a very simple question. It's a very simple question. It's a very simple question. I'll give you 2 minutes to find out the answers. I hope you can get it. So how are you supposed to do this? You have to find out the current density at a distance x from this end. Just have to find out the current density at a distance x. What you have to do is, at this distance x, you just have to find out the radius of the circle. You just have to find out the radius of the circle here. And how will you find out the radius of the circle here? There are different ways of doing it. You can do it by similar triangles. You can do it by similar triangles. Or you can do it by the method of interpolation. Anyways, in any case, r, the radius at this point, will be equal to, from A to B, the length is L, so the change in radius is B minus A. So change in radius per unit length is B minus A multiplied by X. That will be the change in radius. You add it with A and you will get your radius at a distance X. You must remember this. This is a very simple technique of finding out. This has got nothing to do with physics beta. This is purely a technique of maths. This is the radius at this point. Once you have the radius at this point, current density is current per unit area, and current is I divided by pi into this radius square, A plus B minus A x by L square, and that is your exact answer that we were supposed to get. That's it. Do we understand this? How this is done?
Yes, sir.
Was it difficult to do? No, it was not difficult to do. But here there is a special condition given that B minus A is very, very small compared to L. Now again, to go ahead from this stage, we do not require physics. The only physics that we have done in this question is that we have applied this formula in physics. Which formula? We just have applied this formula in physics. This is the only physics in this entire question. Now I can move ahead and do some mathematics here. What I am going to do, I am going to write J as I by pi. And I will take A square common. A square will come common. And then I will have whatever remains will be in the bracket, and I've taken that bracket on the numerator. So it looks like this: 1 plus x by AL into B minus A raised to the power of minus 2. Do we understand how I've done this?
Yes, sir.
This has got nothing to do with physics. Physics comes nowhere here. This is simply math, and I'm going to apply binomial expansion here. Do we understand this?
Yes, sir.
That's it. So how can I write this? I can now write this: J is equal to I by pi A square. This is in the form of A plus x raised to the power of n. So I can just write it as 1 minus 2x by AL into B minus A. Do we understand what I have written it? How I have written it?
Yes, sir.
That's it. Now you can just keep it this way, or whatever you want to do, you can do with this. Do we understand this? This is how this is done. This is all a problem of maths and not such a problem of physics. Do we understand this? Can we move ahead in life?
Yes, sir.
Yes, sir.
Okay. Let me give you one question on this type also, because we have seen the concept. Everyone has noted this down?
No, sir.
This is the next question coming on your screens now. Question number 7 or 8 or whatever you call it. The current through a wire depends on time as I is equal to 2 plus 3t ampere. Calculate the charge that crosses through a cross section of wire in 10 seconds. It's a very simple question, and I'm hoping to get a very simple answer from you. So how are we supposed to do this? It is a very simple question based on the concept that we have already
Yes, sir.
seen. I is equal to dq by dt. This is your instantaneous current, dq by dt. And from there we had devised this formula that total charge flown is integral of I into dt. We can just put the value. So it is integral of 2 plus 3t into dt, and you have to integrate this from 0 to 10. So it will be, if I integrate this, it will be 2t integral from 0 to 10 plus 3t square by 2 integral from 0 to 10. You put the values, and I think the answer that you are going to get is 170 coulombs. Is that so?
Yes, sir.
Everyone understands this?
Understood, sir.
Now, everyone got the answer?
Yes, sir.
Now I can ask another question here. Find out the average current that flows from 0 to 10 seconds. What is the average current that has flown in the wire from 0 to 10 seconds? What would be the answer here for this case? What is the average current that has flown in the wire from 0 to 10 seconds? Yes, my dear friends. Yes. Yes. How do I get the average current, my dear friend? This, if you could understand and imagine and remember, this is your instantaneous current, my dear friends. This was your instantaneous current. Yes. How will I get the average current? Anyone with an answer? Anything that looks like an answer, sounds like an answer, feels like an
17, sir.
answer. 17, that is correct, because your average current is total charge which has flown divided by total time, my dear friends. What we got to do is we got to just remember the definition of these things. If we can remember the definition of these things, things will start to add up. So once I understand this average current, I can find out this average current is total charge. Total charge is 170 divided by total time is 10. So I have the answer as 17 amperes, and that, my dear friend, is your average current. This is how you can find out the average current. To find out the instantaneous current, you have to differentiate it. Do we understand this? Yes or no? No or yes?
Understood, sir.
Everyone understand this?
Understood, sir.
These are the type of questions that can come in your exam. Everyone has noted this down. Okay, let me present one more question for you. Question number 9 or 10 or whatever you call it. Charge as a function of time is given as 2t plus 3 coulombs. Find current at t is equal to 0 and t is equal to 2 seconds. That is question number 1. Find average. Oops. Find average current from 0 to 2 seconds. So this is a question that I have devised for you, made for you. I'll give you 2 minutes to give me the answer for this one. Oh, I think all of you have tried. Let me now jump in and try to solve this. How are you supposed to solve this? To find out the value of, when I say that you tell me the value of current at 2 seconds or you tell me the value of current at 0 seconds, what I am basically asking you is the instantaneous value of current at 0 seconds and instantaneous value of current at 2 seconds. How will I find that instantaneous value? To find out this instantaneous value, I will differentiate this current, differentiate charge with respect to time. So I differentiate charge with respect to time and I simply get current as 2. Time does not come. So at t is equal to 0 seconds also current is 2. At t is equal to 2 seconds also current is 2 amperes. Do we understand this? Yes or no? No or yes? To find the average value of current, I have to find out the total charge that has flown from 0 to 2. I have to find out the total charge that has flown from 0 to 2. Total charge divided by total time. Now, how much is the charge flown? Charge at 0 seconds is 3. Charge at 2 seconds is 7 coulombs. So, how much charge has flown? 4 coulombs charge has flown. Do we understand this? Do we understand this?
Sir,
Yes, sir.
So, what is the average current?
2.
Average current is also coming same, 4 divided by 2. Average current is coming same as instantaneous current. Why is that happening? Because current is constant. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Well, if you've noted this down, let us now move ahead and I'll give you one more for you to understand the difference between different questions. And here comes the next question. Question number 10. Charge as a function of time is given as 2t square plus 3t. I've just changed something. Find current at t is equal to 0 and t is equal to 2 seconds. Find average current from 0 to 2 seconds, and now you will see the difference in the answer that you get. I will give you 2 minutes to sort out this problem. Then let's go ahead and solve this. To get the value of instantaneous current, my dear friends, I have to differentiate q with respect to time. So I can get the value of current as 4t plus 3. Everyone got this? Yes or no? No, yes. Huh?
Sir.
Sir.
Okay, now you can put at time t is equal to 0 seconds, you can get the value of current as 3 amperes, and now you can put the value of t as 2 seconds and you will get the value of current as 11 amperes. Everyone got this? Yes or no?
Yes, sir.
Well done, sir. Then I have this revolutionary formula for the average current. And what is the revolutionary formula for this average current? I have to find out the total charge that has flown divided by the total time. So at Q0, the charge in the circuit was 0. At Q as 2 seconds, the charge in the circuit, the charge that was flowing through the circuit was how much? Huh? 14. 14 coulombs. So how much charge has flown? Delta Q is 14 coulombs. Now I can get my average current. My average current will be 14 divided by 2 and the answer would be 7 ampere. Now you can see here, if you look at the current at 3 at 0 seconds, if you look at the current at 2 seconds, and if you look at the current average current, they are all coming different. Why it is coming different? Because my dear friends, your current is not constant, your current is variable. This is exactly same as what we had done. If your velocity is constant, your average velocity and instantaneous velocity will be same. If your speed is constant, your instantaneous speed and average speed would be same. If your acceleration is constant, your instantaneous acceleration and your average acceleration is same. Do we understand this, or this has gone above our head saying bye bye? We are going, sir. Please forgive us, sir. Bye bye, sir. Enough, sir. Leave us, sir.
Sure, sir.
Understood?
Yes, sir.
Then comes this question. These are the type of questions you will see in your examination hall. So be prepared. Be prepared with these types of questions. They are going to come in your exams. And this is the next question that is coming. The current density at a point is given by this vector. And now you have to find out the rate of, I don't know what is this, the rate of charge flow, whatever is this is, you have to find out the value of this thing. You have 2 minutes to show your talents. So how are you supposed to do this? You have to find out the rate of charge flow. Basically, what do you mean by rate of charge flow? By the meaning of rate of charge flow is the current. Do we understand this? Yes or no? No, yes. Huh? And it is nothing but integral of j dot ds. Do we remember this?
Yes, sir.
This is to remind you that your remembrance, I know how good is your remembrance. Here, this current density, as you can see, is along j-axis. It is a constant, and this is a constant. You don't need to integrate it. You just need to take the dot product. Yes or no? No, yes.
Yes, sir.
You just take the dot product. J dot I will be 0, 2 into 3. It is in centimeter square. So you have to multiply it by 10 raised to the power minus 4. So basically it will become 2 into 3, and the answer will be coming very nicely as 6 ampere. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
I'm not getting any voices from the other boys. Are we still there in the same universe or wandering in the others? Looking to clear JEE in that other universe? Huh? Huh? No one is there? Everyone wandering in some other universe? Huh? Are you there?
Yes, sir.
Same universe no?
Same, sir.
Pakka na?
Sir.
Okay, I thought that maybe you have got a portal, interdimensional portal, and all of you have gone on the other side. Okay. This one comes one of the more tougher question that you might find in your JEE advance more likely. A potential difference is applied to the ends of a wire made up of an alloy which drives a current I through it. The current density varies as J is equal to 3 plus 2R, where R is the distance from the point on the axis. If R is the radius of the wire, capital R is the radius of the wire, what is the current through the cross section of the wire? Well, the diagram is not given for you, but as a hint, as something to help you out, I shall give you the diagram. And once you solve this question, to remember this question and keep it safe. So this is the diagram. This is the section of the conductor or current or the wire that I am showing it to you. You have 2 minutes to show your talents, else I will show mine. How are you supposed to do it? Now to do this, current density is given to you, but that current density is not constant, it is variable. So what you got to do? You got to move a distance r. This is how you apply that technique of integration. You move a distance r and you take a small thin strip whose radius, whose thickness is dr, and you find out how much small current comes in that small segment. So how much small current will come in that small segment? That will be J multiplied by the area of that small segment, and area of that small segment is 2 pi r is the length and dr is the thickness. Remember, whenever you take any such segment like this, the area is 2 pi r dr. Do we understand this? This is the small current. To find out the total current, you just need to integrate this from 0 to capital R. So the total current I will be, what is your J? J is your 3 plus 2R into 2 pi R dr. You just have to integrate it from 0 to R, my dear friends. You just have to integrate it from 0 to R. Do we understand this? This 2 pi will come out, and in the integral you will be left with r dr, 3 dr, that will be 3r, 3r dr, so this will be 3r square by 2 plus 2r square, so that will be 2r square by 3 after putting the limits. This is the answer that you will get, and that would be your current in that wire. Everyone understands this, what we have done?
Yes, sir.
Boys and girls, are we there? We understand what we have done.
Yes, sir.
Yes, sir.
So if any question comes like this is how you have to do this. We did this because I thought that this question may come in your exam, and that is the reason that you have done it. Everyone has noted this down? Yes or no? Huh? I'll give you 2 minutes to note it down. Let me know once you are done. If you're noting down, oops, it's disappeared. Note it down, I'll give you 2 minutes. Okay, then let us move ahead and move on to the most important thing that we have to do in this chapter, because rest of the things have already been done, and that is known as your Ohm's law.
So previous page, sir.
The next thing that we have to do is Ohm's law. Now, what is this Ohm's law? Anyone has any idea about this Ohm's law? Anyone tell me about this Ohm's law? Have you read about this Ohm's law?
Sir,
Yes, tell me, beta.
show your previous page, sir.
Previous place is gone. You can write it from somewhere else. Let us discuss this. What is Ohm's law? First, tell me.
Sir, there is a mistake in the answer.
There is a mistake in the answer. What mistake is there in the answer? What mistake is
2
there in
r
the
cube by 3.
Yes. 2 r cube by 3. You can put r cube by 3. You can put r cube by 3. Doesn't matter, yeah. It's okay. I written it r cube. I said it r cube. I wrote it r square. Okay. Is it correct now?
Yes, sir.
Okay. Has everyone noted this down?
Yes, sir.
Shall we move ahead?
Yes, sir.
Okay. Okay. Ohm's law. What do you mean by Ohm's law? Anyone heard about this Ohm's law? I could not hear you, beta, but I hope that everyone knows what is Ohm's law. Yes or no?
Area of cross section is directly perpendicular to the current, sir.
If the physical conditions of the conductor, when I talk about the physical condition of the conductor, length is area of cross section, is geometry, is temperature. If these things, the physical conditions of the conductor, of any given conductor, it remains same. The physical condition of the conductor remains same, then the current flowing through the conductor is directly proportional to the potential difference across its end. So basically, the current flowing through the conductor is directly proportional to the potential difference across its end. This statement is known as Ohm's law. Everyone understands this, yes or no?
Yes, sir.
Sir.
Then I can write this equation in this form. V is equal to IR. This is the most popular form of this equation. V is equal to IR, where R is a constant. Where R is a constant, which is known as the resistance of the conductor. R is a constant, which is known as the resistance of the conductor. This law is known as your Ohm's law. Do we understand this? Yes or no?
Yes,
No or
sir.
yes? Now this resistance of the conductor depends on what? The distance R of a conductor depends on what? The distance R of the conductor depends on what? Tell me fatafat. Number one, it depends on size, shape or geometry. Yes or no?
Yes, sir.
When I say size, shape or geometry, I also mean the length and area and all those things. Do we understand this? Yes or no? No, yes.
Yes, sir.
Then it will depend on the material of the conductor. It will depend on the nature of the material. Do we understand this?
Yes, sir.
Then thirdly, it depends on the temperature of the conductor. Do we understand this?
sir.
This is known as the resistance of the conductor, and we will hear more about this resistance in the coming class. Right now, what you can see, first listen to me, then write. I'll give you time to write. If you draw a graph between V and I for a conductor, the graph would be coming as a straight line. Do we understand this?
Yes, sir.
V and I graph, if you draw I on the x-axis, V on the y-axis, the slope of this graph tan theta will be equal to V by I, and that will be equal to the distance R. Do we understand this, or this has gone above our head? Saying bye bye.
Understood, sir.
I'll give you 2 minutes to note this down. Okay, now remember this Ohm's law that we are doing is not a universal law. This Ohm's law that we are studying is not a universal law. Not all bodies, not all substances, not all materials are going to obey this Ohm's law. Do we understand this? Yes or no? No.
Yes, sir.
The bodies which obey Ohm's law are known as ohmic substance or ohmic materials or ohmic conductors, whatever you want to call them. Do we understand this? Yes or no? No, yes.
Yes, sir.
Yes, sir.
So I will now show it to you at different temperatures also, these curves. Okay. So remember this Ohm's law is not universal law. Some bodies may follow Ohm's law. They are known as ohmic substances. Do we understand this?
Yes, sir.
At different temperatures, the slope of this graph is going to be different. When the temperature rises, actually resistance increases and therefore the slope increases. We will see this in the next chapter. I mean, the next class, and therefore these two graphs are given. Do we understand this? Anybody
Yes.
which obeys Ohm's law is known as a ohmic body. Do we understand this?
Yes, sir.
Yes.
Anybody which does not obey Ohm's law will be known as a non-ohmic
Yes.
or non-linear conductors. We will see this non-linear and ohmic and non-ohmic conductors in the next class. I will finish this class here on this note. Have you noted down this graph? Both
Minute,
of
sir.
both of these graphs you have noted down?
Yes, sir.
1 minute, sir.
Okay, so I don't have time remaining to complete the next topic, so I will just end it up here rather than leaving it in between. Up till now, everyone has understood what is ohmic substance, ohmic bodies, and they obey Ohm's law, and Ohm's law is not a universal law. Have you understood up till here?
Sir.
Yes.
We will carry on with our journey in the next class. I'll see you tomorrow, and tomorrow probably we will should be able to cover this up. Once we have covered this up, we must understand that I'm not going to go to Kirchhoff's law and series parallel combination. We have already done that. Yes or no? We have done that, na? Series parallel. You understand, na? Series parallel of resistance. So after we are done with this, I'm going to straight away move on to the next part, the heat generated and all these. Even heat generated is done. I will just go through heat generated, and then we'll move on to the electrical measurements wala part. Do you understand this? Yes or no? We understand this? Yes or no?
Yes, sir.
Thank you, sir. So I'll see you in the class. So by tomorrow, we should be able to probably start the beginning of the end of this chapter of electric current. Take care, and I hope that God blesses you. Bye bye.
Sir, 1 minute, sir. 1